We have all held that folded piece of paper in our hands, a blank canvas ready to soar. We carefully give it wings, aiming for the perfect launch. With a flick of the wrist, we send it on its journey. The humble paper airplane, a symbol of childhood wonder, holds within its simple folds the fundamental principles of flight. It's a testament to the laws of physics, beautifully demonstrated in a way anyone can understand. Paper airplanes may seem simple, but they capture our imaginations. They remind us that science is not confined to textbooks or laboratories. It's all around us, waiting to be discovered in the most unexpected places. When a paper airplane takes flight, it's a small-scale demonstration of the same forces that lift massive airplanes into the air. To understand how something as simple as a folded piece of paper can defy gravity, we need to understand the four forces that govern flight: lift, drag, thrust, and gravity. Lift is the upward force that opposes gravity. It is generated by the shape of the wings and how they interact with the air. The wings of a paper airplane, like those of a larger aircraft, are designed to deflect air downwards. This downward deflection of air creates an equal and opposite force, pushing the plane upwards. That's lift. Then there's drag, the force that resists the motion of the airplane through the air. It is caused by friction between the air molecules and the surface of the plane. A well-designed paper airplane minimizes drag by being as streamlined as possible. Thrust is the force that propels the airplane forward. In the case of a paper airplane, thrust comes from the initial throw. Finally, there's gravity, the force that pulls everything towards the center of the Earth. Gravity acts on the paper airplane, pulling it downwards. The design of a paper airplane plays a crucial role in how it flies. The shape, size, and even the type of paper used can significantly impact its flight characteristics. For instance, a paper airplane with larger wings will generate more lift, allowing it to stay airborne longer. However, larger wings also create more drag, which can slow the plane down. The shape of the wings also affects stability. A paper airplane with swept-back wings, like those on a jet plane, tends to be more stable than one with straight wings. Folding the wings to create a dihedral angle, where the wings are angled slightly upwards, can also enhance stability. The weight and stiffness of the paper also play a role. Heavier paper will result in a heavier plane that requires more force to launch and may not glide as far. Section 4. The Great Paper Airplane Challenge. Now let's put our understanding to the test. Gather your materials, paper, tape, and a measuring tape. Design and fold two different paper airplanes, one with a classic dart design and another with larger glider-like wings. Mark a starting line and throw each plane 3 times, measuring the distance flown each time. Observe how the designs perform differently. The dart-shaped plane, with its smaller wings and streamlined design, likely travels faster and farther in a straight line. The glider with its larger wings might stay airborne longer but may not cover as much distance. This simple experiment highlights how different designs affect flight characteristics. Section 5. Conclusion: up, up, and away. The next time you find yourself holding a simple sheet of paper, remember that within it lies the potential for flight. Experiment with different designs, fold, launch, and observe. You are not just playing with a paper airplane, you are engaging with the fundamental laws of physics. As you watch your creation soar, take a moment to appreciate the science that makes it all possible. The science of flight, so beautifully illustrated by the humble paper airplane, reminds us that the sky is not the limit when it comes to exploration and discovery.